All right, homework 5, complex numbers. So we have the 4 main operations: addition, subtraction, multiplication, and division. So I'm going to make sure you guys see how all of those work. So this is the first one right here, and it's an example of addition, which subtraction works almost the exact same way. So when you're adding, you basically just want to combine like terms. So you add the real parts together, you add the imaginary parts together, and then you're just left with one complex number. All right, so you see the real part here is an 11, and then we've got a positive 2, so we're going to add those together, and that will be our real part. So we've got the real parts here, and then these are the imaginary parts. So add 11 and 2, that gives us 13. And then we have a negative 7i plus a negative 5i, so that would be a negative 12i, and that's really all you have to do with addition and subtraction. Be super careful, especially with subtraction, that you're not messing up any of the signs. All right, let's look at 5. 5 is an example of multiplication. These ones work the exact same way that foiling does. So we will multiply first is the 7 times 4, that gives us 28. Outside, 7 times 3i, you multiply the numbers and then attach I to it like that. Same thing with the inside, I times 4 is just 4i. And the last one, I times 3i. So there's a 3, and then the I times I, it does multiply together, to give you an I squared, just like x times x gives you x squared, and then that piece needs to be simplified. So do not forget that I squared is equal to negative 1. So every time you multiply, you're going to replace an I squared with a negative 1. So let me just rewrite what we've got so far, and then we'll combine like terms. Okay, so 3 times negative 1 is a negative 3, and then we can combine up those like terms. Okay, so we've got 28 and negative 3 would give us a 25, and then 21i and 4i gives us actually also 25, but with an I attached. Okay, we want to do a division example. So it looks like 10, or we can go on to the next page. 11 would be a good example to look at. So we've got 18 divided by 9i. So we use something called the complex conjugate here. So if we have a plus bi, the complex conjugate would be a minus bi. And what you do is you look, because you can't have that imaginary number in the denominator, just like you can't have a square root. So we had 2 different rules. If the denominator is a monomial, you multiply top and bottom by that same monomial. All right. And you really, you can just use the monomial I. That's really all that you have to use. If it's a binomial, you're going to multiply top and bottom by the conjugate. Okay, so you can just stick with, if it's just a monomial, you can multiply top and bottom by I. Okay, so we're going to multiply top and bottom by I. What ends up happening, and the reason that we do this, is because this will give us an I squared in the denominator, and I squared can be replaced with negative 1. And that's what makes it just a normal number in the denominator. So when I do this, my numerator, I have 18 times I, and then in my denominator, I have 9 times I squared. So remember, every time that you have an I squared, you replace it with a negative 1. So this, I have 18i, and my denominator ends up being a negative 9, which, since those numbers share a common factor, we could divide by that negative 9. So 18 divided by negative 9 is negative 2, and then you still have that I attached to it. Okay, so one like these ones you would be using the conjugate. So with this one, for instance, you would multiply top and bottom by 1 plus I, and then simplify everything up. All right, last section down here. So we're going to look at just some of the properties. So it's the exact same things that we did way back in Unit 1. So the commutative property of multiplication, that says that you can multiply things in any order that you want. So let's say I'll even just use the values that I showed on number 11. I'll say that 18 times I is equivalent to I times 18. Okay, before I wrap up this video, I just realized there was something that I forgot to do in these previous problems. The directions also stated to name all of the categories or the groups of numbers where these would all fall. So this one is a complex number versus a real number. So this one, as long as it has an I in it, it ends up being a complex number, and you use this. The pure imaginary number was just the b times I if there's no a plus or a minus. So this one is also a pure imaginary number. Okay, so that's going to be part of your answer as well. Let's look at the 2 that I did on the previous page. Apologize for missing that detail. So this one, there's an I in it, so it is a complex number, but it's a plus, or I guess technically a minus bi, so it's not just a pure imaginary number. So we'd say this one's complex, and this one, exact same thing. This one's just complex. It is not a pure imaginary number.